Hello everyone and welcome. I am Lelu and today let's see how to create this stylized smoke in Godot. When it comes to smoke effects in video games, there are two main styles. We have realistic smokes and stylized smokes, which are perfect for games with a toony, artistic vibe and anime-style video games. And that's exactly what we are focusing on today. In this tutorial, I will guide you step by step through the entire process of making this stylized smoke entirely from scratch. And I will also show you how to add physics to it in case you want your smoke to interact with the environment. Also, if you are looking for even more effects, I have created a collection of additional smoke effects that is available in my Patreon page and in my website. In case you are interested, there's the link below. So, without further ado, let's jump right into this. This tutorial will be divided into three parts. First, we will create a simple cloudy mesh in Blender. Then, we will import that mesh into Godot to create a particle system with it so we can get a base for the smoke motion. And finally, we will make that smoke look pretty nice using a special shader, and I will also show you how to add some colors and physics to it. Let's start creating a simple cloud mesh. Right, so here we are in Blender, and I just want to create a very simple cloudy-like object that we can use in our effect. But first, let's go ahead and delete all these objects. We don't need anything of this. Instead, I want to Shift-A and create a new UV sphere mesh. And I really need to increase the density of this mesh because I want to convert this into a cloud. So let's go to this little blue key icon over here. And let's add a subdivision surface modifier. And I really want to increase the density of this sphere. So let's increase this to 3. Okay, so now let's convert this boring sphere into a nice cloud. And in order to do that, I want to use a special option in Blender. I will use the displace modifier. So with this, we can use a texture to control the shape of the sphere. Let's see. For example, I want to create a new texture by clicking here. And now let's go to the texture panel over here. So here we can select any texture we want. And let's see, for example, this wood texture. Okay, this is crazy. But for the cloud effect, I think I will use the Voronoi texture. So let's start with this. And I want to do some changes to this texture. For example, I want to set the distance to be distance squared. And I want to invert this texture. So let's go to the color ramp and let's grab these black colors and white color so we can invert the position. So now we get this bubbly effect. And now I want to play a bit with the intensity value and with the size value to see if I can get something interesting. Let's see. In case you are interested in getting this exact same result, I am here using an intensity of 1.6 and a size of 1.4, basically. Okay, let's go back to the modifiers. I just want to show you one more thing. Just in case you want to create more variations, you can easily do that by using this special method. If you go to coordinates and object, here you can use any object to control the texture that is modifying this sphere. So for example, I will Shift A and create a empty object. So now I can select the empty object. And if I move it, you can see how this is modifying the shape of the sphere. And this is a very quick way to get multiple variations. Just wanted to mention that in case you want to get different variations, you can do that very fast this way. But for now, I will delete this. So I want to keep this tutorial simple and easy to follow. All right, we will need to export this to Godot. But before that, we need to do something else. Let's see. If I disable this optimal display, you can see how this mesh has too many polygons, which is not good for performance. So in order to fix that, we will use a special modifier. So let's click over here and select a decimate modifier. And over here, you can see the total faces this cloud mesh has. Right now, it's over 30,000 faces. So we really need to optimize this. And I will reduce these faces with a ratio of 0.01. Okay, this is much, much better. Also, I want to press W and select Shade Smooth so we don't see these polygons popping out. And that's basically it for the cloud. Now let's go ahead and export this as an OBJ file. And I want to export this without any material. And of course, applying all the modifiers I have. Let's name this static mesh cloud. Okay, we have created a simple cloud, but a smoke is composed by multiple clouds floating around. Let's see how can we do that in Godot. Right, so here we are in Godot. So now let's go ahead and let's import our cloud mesh we have just created. And also for this tutorial, we will need a texture. And over here, I have some random textures just to play with. And I will leave the links in the description so you can download this for free. So let's import this as well into our project. Okay, now let's go ahead and create a GPU particle system. And let's name it VFX Stylized Smoke. And in order for these particles to work, we need to create a particle process material over here. And also, we need to assign a mesh. In this case, I will select my cloud mesh. Okay, we have a lot of cloud meshes falling down. This is because of the gravity. So let's go to the particle process material, into accelerations, and set the gravity to 0. Instead, I want to give it some velocity. So let's go to spawn, velocity, and I want to give it a velocity up into the y-axis. So let's put this into the y-axis with a speed of 0 and a random velocity between 3 and 4. Okay, maybe we can give it some more variations. So let's go to position, and I want these particles to spawn into a sphere position with a radius of 0.5. Also, just to give it some more variation, let's go to particle flags and enable rotate Y. With this, we can make the smoke spawn into a different rotation. So let's go to angle and set initial rotation with a value between minus 180 and 180, just to give it some interesting variation. And maybe we can give it some velocity into the x-axis as well. So let's go again to velocity, minus 0.3 into the x-axis. But maybe this smoke is too big. So let's go to display into the scale, and let's set a random scale between 1 and 1.2. But also let's create a new curve to control the scale. So I want this smoke to start small, like over here, very small, but then I want it to go big. but not too much, maybe over here. Okay, let's change some more stuff. For example, let's go up and I want to set the amount to 20 so we have much more clouds. And also let's go to time and let's set the FPS to 60 FPS so the animation looks more smooth. Great, so with this we already have the motion and the clouds ready to go. But now we need to do two more things. First, I would like these clouds to vanish, to disappear at the end. And then I want to make these clouds to look more like an anime toonish style. And in order to do that, we will need to use a shader. So let's do that. Let's go to geometry, into material, and let's create a new shader material. Let's create a new shader, and this will be a visual shader. And let's name it, for example, smoke shader. Cool. Now let's go and open the shader over here by double clicking it. And as you can see here, we have the shader graph. And here we can create our shader. But first, I want to go ahead into modes and I want to set the cool mode to be disabled so we can see both sides of the sphere. And I want to set the diffuse mode to tune and the specular mode to tune. And this helps a bit, but it's not too good yet. It looks quite weird. So we will need to modify this shader. But first, let's make this smoke disappear. In order to do that, I want to use a texture. So I will right click and create a texture to the parameter. And I will name it dissolver texture. Set it to color. And in order to use this texture, we need to sample it. Okay, so I want this texture to control the transparency of the clouds. But because this is a black and white texture, I don't need to use all the colors of the texture. I will only use the black and white information. Okay, it looks quite weird, as you can see, because we will need to assign a texture. So let's go to the smoke, let's go to the material, and now we will see these new shader parameters, and here we have the dissolver texture parameter. So here we can assign any texture we want. And let's try, for example, let's see this one. Okay, I will leave this for now. Let's continue. I also want to control the scale of the texture. So I will create a UV scaling node. And let's create a parameter, a vector to parameter. And I will name it texture scale. And it will start with a value of 1 and 1. So this will control the scale of the texture. So here we can put any values. For example, I want to set a scale of 0.5 and 0.5. And now I want to control the transparency of these clouds. In order to do that, I will use a parameter. So I will right click and I will create a float parameter. I will name it alpha threshold. And let's connect it over here into the alpha threshold value. Okay, so let's see what happens now if I modify this value over here in the material. If I increase this value, you can see how the smoke disappear. So this is amazing. This is exactly what we need. The only problem is that We only need these clouds to disappear at the end of the smoke. So in order to do that, I want to use a special technique, a special trick. And for that, I will, instead of using this parameter to control the alpha threshold, I want to get the color information of the particle, but I want to get only the alpha channel of the particles. And I will use the alpha of the particle to control the threshold. So let me show you. Let's go back to the particle process material. And here into the color curves, let's create a new alpha curve. So I want my alpha threshold to start in a value of 0, and then it goes to a value of 1, like so. Okay, this is looking nice, but maybe the smoke is disappearing too fast. So let me adjust this curve a little bit, like so. The smoke base is completed. There are two ways to make this smoke look more cartoonish. You may prefer to choose one or another depending on the style of your game, but I want to show you how to do this in these two different styles. First, I will show you the more simplified version of this smoke. So I want to go to the shader once again. Let's open the shader. And here what I want to do is to use the color of the particles to control the emission color of this smoke. And now you can see how it looks more flat and simplified. But also I want to create over here a color constant parameter with a black color. So I don't want the albedo color to affect the color of the particle. And yet, this is one way to do it. This is the most simple way to make this smoke look more like a flat, stylized smoke. But also, I want to give it a nice color. So let's go to colors. Over here, you can pick any color you want. But I want to use this time the color ramp option to create a color gradient. And I usually want a smoke to start very bright at the beginning, and then I want it to go darker at the end. So this way it looks more interesting. This is usually the way I prefer this smoke, but feel free to experiment, to add your own colors. You can also use very intense colors. So for example, if you enable this use HDRI option, you can really push these values to something more intense. For example, I will set a blue value of 1.4 and let's play a bit with this to see if we can get a really crazy result. For example, this one as well. Be creative, change the texture, change the colors. I just show you the way, but you have to put your own creativity to get your own unique smoke effects. Okay, for now I will go back to my default gradient color so I can show you the other way to do this smoke effect. This smoke is perfect for minimalistic, simplified style video games. But now let's see how to do something more advanced. Let's see how to add some hard-edged shadows to this smoke. Let's go back to the shader editor. And if we want to add shadows to this smoke, we will need to delete this black color and connect the color of the particle right into the albedo. And once again, we are getting these ugly smoke shadows back. But what I want to do this time is to modify the way the light affects this object so I can make it look more toony. So I want to quickly explain you what is the plan to do this. Let me open my PowerPoint presentation very quick. Okay, let's talk a bit about cel shading and how it works. Cel shading is when you render something using multiple bands of color rather than a continuous gradient. For example, here in the image you can see how the shadows gets divided into just 4 segments with this hard edge. Most video games only has a 2-band cel shade like this, when there is just a full bright side and a full dark side. One of my favorite examples of simple cel shading is The Legend of Zelda: The Wind Waker. In this example, I have a 3D object which is composed by a couple of vertices and faces, and each one of these faces are looking into a direction. These are the normal vectors. Also, now let's say there is a light source, the sun, which is pointing to a direction as well. Let's take a look at this face over here. If the direction of the light is opposite to the direction of the face, then this face will get 100% bright. Now let's see this other face over here, which is pointing to a more open angle. This one gets less brighter. Let's say this is just 40% bright. And finally, this face over here, which is pointing in the same direction, has no brightness at all. It will be very cool if there was some simple mathematical operation that can compare both of these directions and tell us if they are pointing in the same direction or not. Well, there actually is a mathematical operation that does that, and it's called the dot product. So maybe we can use that. Let's see. Let's open the shader once again. This time I want to go to the light section of the shader. So here we can configure the light of this shader. I will right click and look for the light direction, and also I want to look for the normal directions of the cloud mesh. So I can go ahead and do a dot product between the light and the normal direction. Oh, and also I need to remap this result, because this result originally goes from -1 to 1, and I want to convert this result between 0 and 1. So let's see. So now we get the default light, but this time I want this to look like a cel shade. So I will take this result and I will go ahead and create a texture 2D, set it to color, and I will choose a gradient texture 1D, so I can connect the result of this dot product into my texture and then connect this into the result. Now if I go ahead and configure this color gradient, here I can control the shadows and the light, and I can also set my own colors as well. But because I want this to be like a toon shade, I will select the interpolation mode to be constant. So now I can get this interesting result. And this is basically the basics of how cel shading works in video games. But I want to add some more stuff here, and I want to add some mathematical operations, because, for example, I would like these shadows to also follow the curvature of the cloud and give it some attenuation as well, some more properties. So, and to have better control over the shadows, I will need to use some math operations and stuff. So probably it's not a good idea to do all this math stuff here into a visual shader. So for this time, I will prefer to use a shader code. If I click over here in this icon, you can see that here is the code of all these shader. Basically, when we create a visual shader in Godot, it automatically generates a shader code for us, so we don't need to type any kind of code in the shader, which is perfect. In 90% of the cases, I prefer to use just a visual shader because it's visually more intuitive and simple. But in this case, since we will need to do some multiplications and additions and math stuff, it's probably better to just use a shader code. So I can just type all of that in one single line of code. Unfortunately, we cannot modify this shader code here directly. So we will need to copy all this code, and now I will go ahead and create a new resource, create a new simple shader, just a shader. Let's name this smoke cell shaded. So let's open the smoke shader code, and I will replace all this code with the code of our smoke shader. Okay, this is basically the same shader, but in code. You know what? Let's go to the smoke, and I will remove this smoke shader, and instead I will apply this new smoke cell shaded. So you can see it's the exact same shader, but this time it's in code. So I will go to the light section of the shader, and here you can see that we are doing the dot product between the normal and the light. But I have already prepared a code for this. So I will delete all this, and over here I have created all this math stuff that we can use to control the cell shading effect. So I will just copy this code. You can find this in the description of the video. Just copy this into the light option. And there's an error. This is okay, because I also need to copy these variables I have created. So let's also copy this. And let's put it over here before fragment. Also, let's delete this. I have already created one in my code. Great. With this, now you can find these new parameters: the shadow roundness, light attenuation, and color gradient. See, I will create a color gradient. And once again, here we can control the shadows. And since we want this to be a hard-edged shader, I will go to interpolation and set this to constant. So now we can control these values, and you can also change the color of the shadows if you want to have, for example, blue shadows or lighter shadows. Now you can do this very easy. And also we can control the light attenuation. For example, let's put a light attenuation of 2.1. Finally, if you want to add some physics to these particles or collisions, that's very easy to do. You only need to click in the particle and go back to the particle system, and over here you can find the collision option. So you need to set this to rigid, and you can set the bounciness and the friction of the particles. So now you can go ahead and look for a GPU, and here you can have a bunch of options. You can add an attractor if in case you want to attract the particles or repel the particles. You can use this. You have collisions, but for example, you have a collision sphere, a collision box. I will create a collision box, and as you can see, if I move the collision box over here, you can see how it collides with the smoke clouds. So if you want an object or a character to collide with particles, you only need to add one of these special colliders. Alright, here we go, that's it. Feel free to change the colors, the textures, and parameters. That's how I have made all these different variations that you can get on my Patrons page or in my website. They are all available there. So that's essentially it, guys. I hope you have enjoyed this tutorial. Thank you for watching. See you.